طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. Any questions يا شباب before we proceed? Any questions? Okay. طيب. So what we did the day before yesterday was we looked at permutations, and we said that if we consider a set with n elements, then how many different orderings of the set of n elements we have, or how many permutations basically we have. We said it is n factorial, صح? And then we talked about an R permutation, right? Which is in how many different ways I can choose R elements from the n elements where order matters, where order is important, right? And we called that, we denoted that by PNR. We denoted that by PNR. So now what we will do is we will look at how we count different ways of choosing elements from a certain set, however, without putting emphasis on the order, or regardless of the order. What is important is what elements are chosen, right? What elements are chosen. That's why these are basically called combinations. And basically an R combination of elements of a set is an unordered selection of R elements from the set. Is an unordered selection of R elements from the set. طيب. Why don't we have an N combination? ايش هو N combination? How many different N combinations do we have from a set with N elements? One. ما في غيرها لأنه it's unordered, صح? Because it is unordered, right? So this is basically what we call an R combination. An R combination is simply a subset of the set with R elements. Okay, so it's a subset of the set of N elements which contains R elements, right? Which contain R elements. Right. Just like we denoted the number of R permutations in a set of n elements as P and R, we are going to denote the number of R combinations of a set with n distinct elements by C and R, okay? By C and R. There is also another notation that we will use, which is basically n choose R. We call this n choose R. And by the way, this is called the binomial coefficient, okay? This is called the binomial coefficient. Right. So now, let's see. Before I define what is the value of C and R, okay? Who can tell me how can I compute C for 2? So C for 2 is basically what? Is the number of subsets, the number of different subsets of size 2 from a set with 4 distinct elements, صح? From a set with 4 distinct elements. What is the value of C42? What do you think? What is the value of C42? How many different subsets of size 2 can we have from a set with 4 elements? لساتها مش واصلة؟ 4. Why 4? طيب, let me do it the other way around. P42, what's the difference between P42 and C42?
C42 where if the sets are different. C42 doesn't matter. The order doesn't matter.
The order of the two elements in C42 does not matter, صح؟ طيب وال P42 ال P42 matters, right? طيب, so what do you think? What is what is C42 if you want to think about it in terms of P42? In terms of P42, what is C42? So if I said that, you know, C42 C42 is equal to P42. Now I know for sure that this is wrong. ليش? Because P42 order matters, صح? طيب, if you want to remove order, what do you need to do? Divide by اللي هو ايش؟ Divide by 2. Because see, if you have any subset of size 2, what are the different orderings of those elements? يا اما A1 A2 او A2 A1, صح ولا لا؟ في order تاني؟ Is there any different order? There's no other order, right? So C42 is nothing but P42 divided by 2, which is 4 times 3 divided by 2, which is equal to 6, right? Which is equal to 6. So now let us go and define exactly what is CNR. Okay, so the number of so the theorem says that the number of R combinations of a set with n elements, where n is a non-negative integer and R is an integer between 0 and n inclusive, equals n factorial divided by n minus R factorial multiplied by R factorial. Okay? طيب. So now if we would like to think of kind of a combinatorial proof for this theorem, then let's do what we did in the previous question when we looked at C42. Okay, so I have C and R. So C and R is going to be equal to P and R. صح؟ ايش هو ال P and R? What is P and R? N factorial divided by n minus R factorial. صح? So it's basically P and R is n factorial divided by n minus R factorial, صح? But this number includes all arrangements of sets with how many elements? All orderings of sets with R elements, صح? طيب, how many orderings do we have? If you have R elements, in how many ways can you arrange the R elements? R factorial, صح? R factorial. So can we use the division rule in this case? We can use the division rule because we have R factorial different arrangements and we are considering all of them to be ايش? Considering all of them to be the same. We're considering all of them to be the same. So we can employ the division rule in coming up with well, I just need to do it the other way around. So in coming up with n factorial over R factorial times n minus R factorial. Okay, شباب? طيب. This corollary, who's going to prove this corollary to us? The corollary says, let n and R be non-negative integers with R less than or equal to n. Then C and R is the same as Cn n minus R. How can I prove it? Hint, it's very easy. Go ahead.
The n minus r will be r, then it will be multiplied by n minus r.
Yeah, just plug in C n minus R, plug it in here, صح? Just use the theorem. So C n minus R by the theorem is equal to what? N factorial divided by n minus R factorial, صح? Multiplied by n minus ال n minus R و all factorial، صح ولا لا؟ طب هذا ايش بيساوي؟ n factorial n minus R factorial. Now what is n minus R? It's a one-liner. Okay, it's a one-liner. طيب. Okay, so just like what we did day before yesterday, I'll give you 5 minutes. Please go ahead and try to solve these 3 questions, and then we will solve them together. Okay, so let me put 5 minutes on my clock. And this is 5 minutes. يلا, one more minute and then we will go over them. Okay. So let's see. Okay. So how many ways are there to select 5 players from a 10-member tennis team to make a trip to a match at another school? So here, when I want to choose the 5 from the 10, does the order matter? The order does not matter, صح? The order does not matter. So in this case, what will be the answer? Well, it's going to be C. أيوة.
10-5.
C 10-5, which is also 10 choose 5, which is also 10 choose 5. Okay? Fine. Let's go to the second question. A group of 30 people have been trained as astronauts to go on the first mission to Mars. How many ways are there to select a crew of 6 people to go on this mission? And there is a note here which says, assuming that all crew members have the same job. So basically, when I choose the 6, I'm not, putting the 6 into specific jobs. Huh? They all. I'm just basically choosing 6 out of the 30. So how many different ways do I have? 30 choose 6. صح? So you can say either C 36 or 30 choose 6 or 30 choose 6. طيب. Let's take the third example. How many bit strings of length n contain exactly R ones? How many bit strings of length n contain exactly R ones? Go ahead.
And choose R.
N choose R. Why?
Because
What do you choose here? What
we have n possible positions.
we have n possible positions.
We want to choose R ones, and the order does not matter. We just want the number to be R.
Exactly. So basically, the problem here is that we would like to choose R positions from the available. How many positions? From the available n positions. To basically assign ones. Because if you put, once you choose the positions, like the first, second, and fifth, when you put 1, 1, 1, does it matter? It doesn't matter, صح? In order of what is this one or this one is coming before that one, it's exactly the same as choosing R positions from the available n positions. Okay, that's why it is equal to n choose R. So this is equal to n choose R. طيب. using the corollary, can anybody tell me why is it also the same as n choose n minus r? What will be the n choose n minus r in this case?
Zero.
The positions of zeros. And if you have r1s, how many zeros are we going to have? N minus r. So the problem of choosing r positions from n positions is exactly the same as the problem of choosing n minus r positions, or the other n minus r positions out of n. Out of n positions. Okay, شباب? واضح? Any question on these examples?
It wouldn't be different. I mean, the bit string, if we change the position of one, it would be different. So
In positions, ما هو, if you change the positions, then this is what we are counting. The different positions, صح? لكن on the same positions, 1, 2, 3, until, for example, the rth position, when you are putting the ones, does it matter the ones, how do they look like, or which one did you assign first? No, because they are all the same. Okay, they are all, so we are really counting the different positions. Okay, we are really counting the different positions. طيب. So let's do this example before we go to the activity. Okay, before we go to the activity. Suppose that there are 9 faculty members in the math department and 11 faculty members in the computer science department. How many ways are there to select a committee to develop a discrete math course at a school if the committee is to consist of 3 faculty members from the math department and 4 faculty members from the computer science department? What do you think?
9 choose 3 multiplied 11 choose 4.
Right, so we have here one answer. It says 9 choose 3. Nine choose 3 multiplied by 11 choose 4, which is, by the way, the same as C9 3 times C11 4. طيب. So first of all, why did you use the product rule?
Because we have like P1 and P2, we want to. I'm not sure how can I explain.
Okay, so basically, we did not use the addition rule or any other rule. We use the product rule. Why? Because in 9 choose a 3 will give you what?
Possible ways to
The different combinations of math faculty in the committee, صح? The different combinations of math faculty. And what about the second one? The different combinations for the computer science faculty, صح? طيب. In order to count all of them, each one of those can be part in any of the others, صح ولا لا? Right? So each, group of 3 faculty members from the math department, we can associate them with any of the 4 possibilities from the computer science. So that's why we use the product rule. Okay, that's why we use the product rule. Yes.
Here we are assuming that no faculty member is simultaneously in both.
Exactly. Here we are assuming that no faculty member is simultaneously belongs to both departments. So each department has its own faculty members. Okay. Okay. طيب. So let's go to the. In fact, we can also go here. I don't think that you need the slides. So let me. Yeah, here it is. Okay, but let me give you the papers. Okay. So you I'll give you 10 minutes, to solve these 3 questions. ايش رايكم? I'll give you 10 minutes and then we will solve them together. Okay? And then we will solve them together. Make sure you write your names and IDs and don't leave the classroom before you upload it to the grades. But we will solve them. We will solve all of them together, inshallah. We will solve all of them together. And by the way, this is not only on combinations or permutations. Okay? This is on both permutations and combinations.
Yes. The second question. It says 17. Does that mean all the others are possible? They might be true.
17 means
17 true.
وإذا الفاصل نحط يعني one is A, two is false إذا ما إذا ما يكفي
يعني أحس أي ما أنا تخص لا permutation ولا ممكن أكون غلط يعني ما
A و A choose two
يعني عندنا اللي هو
يعني قلت هذا خاص أكيد
أقدر حتى ثلاث بعد ما نختاره ما هو أتوقع السي
لازم هذا يكون
أسئلة جدا مهمة الأسئلة الاكسرسايز
طيب يلا let's see how we can solve these questions. Let's start with the first one. Where do I want to go here? Okay. Tamam. How many ways are there for 8 boys and 5 girls to stand in a line so that no 2 girls stand next to each other? And there is a hint here. First position the boys, and then consider possible positions for the girls. Who would like to give a shot for this question? Go ahead. Yeah.
So we have 8 boys and in total 5 plus 8 positions. 5. So 8 boys and 13 positions.
8 boys and 13 positions. طيب.
So maybe we can say P of 13, 8.
P 13, 8. طيب. Do you agree with this answer? You don't agree? Why not?
Where are the gifts?
Huh? What's wrong with this answer?
No position or result for the.
It says here, I cannot have 2 girls next to each other. I cannot have 2 girls next to each other. So you really did not use the hint that was given in the question. So if I want to use the hint that is given in the question, first we need to place the boys, صح? So how many positions for the boys? Well, we have B1, we have B1, B2, B3, B4, B5, B6, B7. We have 8 boys, صح?
Yes.
B8. Right. So now, the boys, in how many ways can I position the 8 boys? 8 factorial, صح? So this is 8 factorial, or P88, right? So either you say P88, or you say 8 factorial. They are both the same. Right. Now, for each one of them, I need to place the girls. What are the positions that are available for the girls? We have how many? We have 9, صح? طلعوا يا شباب. We have basically, this is P1. Why it's not writing? P1, P2. In fact, let's make it girly a little bit. شو رايكم? Let's use another color. Yeah, we have to become ايش رايكم? This one? Okay. So we have P1, P2, P3, P4, P5, P6, P7, P8, P9. So how many positions do we have for the girls?
9.
We have 9 positions. Right. And I need to place 5 girls, right? In how many different ways can I place 5 girls in among these 9 positions? P9, 5, صح? And in both cases, order matters. مظبوط ولا لا? In both cases, order. So here we're assuming that we do not have identical twins. صح? We don't have identical twins. So basically, this will be P88 multiplied by P9, 5 multiplied by in P9, 5, which is, by the way, we can write it as okay. So we can write it as 8 factorial times, now what is P9, 5? 9 factorial divided by, which is 4 factorial, صح? Which is 4. واضح يا شباب؟ طيب, let's go to the second question. A professor writes 40 discrete math true-false questions. Of the statements in these questions, 17 are true. If the questions can be positioned in any order, how many different answer keys are possible? Yes.
We think it's P40, 17.
P40, 17. Do you agree? Yes.
Choose 40, choose
40. So now we have two answers. 40, choose 17. طيب. Why P40, 17?
Since the questions can be positioned in any order, they're not dependent on each other. We can position them in any way, and each permutation corresponds to a different answer sheet. So we use permutations.
Okay. So basically what you counted is you counted the number of ways to position the 40 questions. صح? Kind of. It's not even correct. Why did you choose 40, choose 17?
Because the slide says our combinations used to an order selection. So I think it's the reverse. It's not
Here, we are not counting how many ways can I place the questions. We are counting how many ways can I have different answer keys. The answer keys consist of what? Consist of true, false, صح? Does it differentiate between two questions if two questions are true? No, if the first one question is true, the second question is true, whether you put the first before the second or the second before the first is the same. So in this case, which answer do you think is the correct one? The 40 choose 17, unless if we have here somebody raising his hand if he has another answer. Yes?
We did 40 choose 23 because 17 are already true. So
Because 17 are already true.
So we do this from the other 23 questions.
So basically you said it is 40 choose 23, صح? طيب, شو رأيكم? Both are correct because this is how you can place the 17 true questions. Oh, I don't have here. How can I have? طيب, so basically, let's do it this way. So this one will tell you where to place the 17 true answers. Huh? In your answer here, this is where to place the 23 false answers. And they're exactly the same. Because once you place the 23 false answers, you are actually placing the 17 true answers, right? So both of these are equal. And in fact, if you go back to the corollary, it's exactly the same as the corollary, huh? It's exactly the same. So basically, this is the answer, right? طيب, let's now go to the last one. A coin is flipped 8 times, where each flip comes up either heads or tails. How many possible outcomes are there in total? ايش رايكم? Yes. 2 to the power 8, صح ولا لا? Isn't this the same as, you know, how many bit strings are there of length 8? It's the same as how many bit strings of length 8. So 2 times 2 times 2 times 2 It's basically 2 to the power 8. Right. How many contain exactly 3 heads? 2 to the power of 5. Do you agree? 8 choose 3. ليش 2 to the power of 5? أنت 2 to the power of 5 يعني let's look at his answer, 2 to the power of 5. If you look at 2 to the power of 5, it's as if, for example, he said, well, the first 3 positions are heads, and the rest are all the other combinations, صح? But is this the only 3 heads that we have? We can have 3 heads like this, صح? مظبوط ولا لا؟ And we can have it's base, that's why it's not 2 to the power 5. It's basically 8 choose 5. It's exactly the same as you need to choose 8 positions or 8 orders of those flips, right? Of those flips that contain exactly 3 heads. So basically we have 8 choose 5. Right. How many contain at least 3 heads? Yes.
2 to the power 8 minus 8 choose 2 plus 8 choose 1 and 8 plus 8 choose 0.
Okay. So basically, and notice here you are using a plus. You're not using product, صح؟ ليش؟ 2 to the power 8 is the total, صح؟ طيب, and then what do you want to do? If you want at least 3 heads, the easiest way to count at least 3 heads is to count all of them and to get at most 2 heads. At most 2 heads. ايش يعني at most 2 heads؟ يعني 2 heads or 1 head or 0 heads. صح؟ 2 heads, 1 head, 0 head. So that's why it is basically the total, 2 to the power 8 minus 8 choose 2, how to choose 2 heads, plus 8 choose 1, how to choose 1 head, plus 8 choose 0, how to choose 0 heads.
كيف هو 8 choose 0 ما أعرف.
8 choose 0. يعني from 8 flips you will get no head. In how many such flips will give you no head? If they are all tails, صح؟ كم واحدة منهم هدول؟